Hello, everyone. About this course, we will introduce some RSTP lab guide because we already know if you deploy the STP or maybe RSTP, you can solve the loop in your network. And about RSTP, we can provide more mechanism to improve your network conversion faster. So about this lab, we will hope the key configuration of RSTP, you can know it. And first, let's say the background. If now on our network, we want to adopt the redundancy and backup design, right? Because in your network, if you have some single failure, maybe your lots of important service cannot provide successfully. So in this scenario, we hope if one device or maybe one link is broken, we can continue use a backup one. And one technology of the redundancy and backup design is STP. And RSTP is a rapid spanning tree protocol, and it can provide a better mechanism compared with STP. So if you are the network administrator of the company, we hope you can master the configuration to meet some requirement. And about this lab, we have 5 purposes. The first one, we hope you can understand and master the working principle of RSTP better by the lab. And you also can master the working principle and the modification methods to how to make the bridge priority in RSTP, and also can change some bridge priority to affect the root bridge election. Because in the RSTP, you also have to select one switch to become root bridge. And the second one, you have to master the function of the port cost value, because the two function of STP is select who is root bridge, and the second one to elect the rule of the interface. So you have to know how to change the parameter of the link cost value. Then you can select some special interface to become RP or maybe to become DP. And also, you can master the function of port priority in the RSTP convergence, and then you can know how to change the port priority, finally to select the RP. Except the link post value, you also can change the port priority. And the last one, we hope you can master the commands, how to check the RSTP status and also the application scenario. So this is the purpose. And about the topology, we already write down here on the left. We have 4 switches, switch 1, 2, 3, and 4. And you will find there are lots of loops, right? If you don't enable the RSTP, maybe you directly receive some message from the terminals, there will be a loop. Maybe you will see a broadcast flood. And then all the link cannot provide the service for the normal message. So that's why you have to use RSTP to avoid the loop. At the same time, you can provide the backup link. And the requirement is about these 4 switches. We hope that switch 1 can be a root bridge, and the switch 2 can be backup root bridge, right? Because the different rule of the bridge finally will design what's your interface rule, right? Because we have to blocking some interface, and about the blocked interface cannot provide the forwarding function. The second one, we hope you can change the cost value of interface, and finally to make the port gigabit 01 of switch 4 to become RP root port. And the third requirement, you can change the priority of the interface in switch 1 and makes the interface of switch 2 to become RP. So these are 3 requirements. Of course, finally, if you change these parameters, some interface will be blocked. We hope you can design the root bridge or maybe design the cost value of interface. Finally, the higher bandwidth interface can provide the service for our network, and the lower bandwidth maybe we can block, right? So as this in this scenario, we can force the message as much as possible. In order to meet the requirement, there's some configuration plan. First step, you have to enable the STP on 4 switches. And the second one, you have to change the priority of switch 1 and switch 2. Lower priority value will be better. And the third one, you have to change the cost value of the switch 4 interface. And the last step, you have to change the port priority of the switch 1 interface. And then let's see the detail, how to do the configuration and meet the requirement. First is you have to enable the STP function and also choose the spanning tree protocol to become RSTP, because by default, the mode is MSTP. So we can change one by one. On switch 1, configuration page, enable the spanning tree, right? And then you have to choose the mode to become RSTP, right? To become RSTP. Otherwise, it will be MSTP. And the next step, the same. We only now enable the function of switch 1, but both switch 2, switch 3, and switch 4, all of them should enable the RSTP. Now on switch 2, you can check first. Show spanning tree. By default, we don't enable the function, right? So you have to enable first. And if you enable, you can check the spanning tree again. You will find now we use the version is MSTP, not about RSTP. So you have to change the mode to become RSTP, right? And also same with switch 3. Spanning tree, and the spanning tree is the mode to become RSTP. And also switch 4. Spanning tree of the RSTP. Okay, so there are 4 switches. And the next step, you have to change the priority of switch 1 and switch 2. Then you can make switch 1 to become root bridge, but switch 2 is a backup root bridge. Okay. And how to select a root bridge? We will compare 2 parameters. One is a root bridge priority, and the second one is a MAC address. And because your MAC address cannot be changed, right? So you can change the priority of the switch. By default, all the switch, if you enable the function of RSTP, the value will be same. 32768. So you can change the priority. Switch 1 has lower priority, lowest, and the switch 2 have the second lower priority. So switch 1 can be root bridge, switch 2 can be backup root bridge. And the command on switch 1 is spanning tree, the priority to become 4096. Okay. And if you change the priorities, it will do the negotiation again because you change the parameter. And about the switch 2, spanning tree priority. And you can check when we set the priority, we have some limitation. The bridge priority in increment of 4096. So you can use the priority 0 or maybe A192, but you cannot use a priority like 40, right? For example, now switch 2 is a backup, so the value should be bigger than switch 1, like A192. Okay, so switch 2 will become backup. Then you can check on switch 1, show span tree summary. You will find who will be the root bridge, right? The bridge priority is 4090, and this bridge is the root. And the bridge ID is switch 1 bridge ID. You will find the root bridge ID and the switch 1 MAC address, they are same. So now switch 1 is the root bridge. If you check on the switch 2, show span tree summary on switch 2, you will find this switch is the root bridge, and this is switch 2 MAC address. This MAC address is different with the root bridge. So this switch is not the root bridge, but it has higher priority of A192. Because on the switch 3, if you check the priority, you will find switch 3, the priority is bigger than switch 2. So switch 2 is a backup. Then the next requirement, we want to change the cost value of the switch 4 interface, gigabit 0/1. Because about switch 4, we only have one interface will become RP. The RP will have the lowest cost value to the root bridge, right? And 3 interface, we hope this link maybe has higher bandwidth. We hope this interface can be RP. So in this scenario, you can change the cost value of the switch 4. And how to make the interface to become RP, there are 3 steps. If the priority of switch 1 and switch 2 changed, right? Now switch 1 already becomes a root bridge and switch 2 is a backup. So about the switch 4, the BPDO received from switch 3, switch 1, switch 2, the best priority will become gigabit 02. So compare 3 BPDO from 3 switches. For example, the cost value in the bridge and in the bridge of gigabit 0 and 1 will be 40,000, right? From switch 3 and switch 2. And the cost value from gigabit 02 is 20,000 directly received from root bridge. So by default, switch 4 will receive gigabit 02 to become RP, right? And compare the bridge ID. The bridge ID is post of the bridge priority and device MAC address. And the priority will compare the first, smaller value will be better. And according to this part, the value of gigabit 00, this is the interface connect with switch 3. The value is 32768. And the value from gigabit 01, this is the bridge connect with switch 2. The value will become A192. And if you compare the priority of gigabit 2, connect with the switch 1, the value is 4096. So compare the bridge ID directly connect with switch 1 also is better. And if you compare the port ID in 3 BPDOs, and the port ID will be composed by the port priority and also the interface number. Smaller ID will be better. So if you don't change anything, you can check on your switch 4. Show spanner tree summary. Who will become RP? Gigabit 02, right? This interface will become our RP because it has the best priority. So now you can change the value to become bigger. For example, to make this interface bigger than the cost value 200,000, 20,000. So this interface will has lower priority than the other two interface. And the command is enter gigabit 02 and use the spanner tree cost value to become 40001. Okay. Now, if you change the parameter, then the spanner tree will calculate again. And before we convergence successfully, the network cannot provide the function to help us force the message out. This also is a reason why in some important network, we don't like to use the spanner tree protocol. Okay. And if you change, now you show the spanner tree summary again. You will find the rule will become alt port and the data is broken. Now the gigabit 01 will become RP. It has higher priority, right? So this is the command. You can change the interface status. And the next requirement, we hope we can change the priority of gigabit 01 of switch 1. Finally, the interface of the gigabit 01 from switch 2 can become RP. So which parameters we can change? You can analyze something. Switch 2 also will receive the BPDO, but switch 2 has 4 interfaces, right? 2 link can directly connect with switch 1, 1 link connect with switch 3, 1 link connect with switch 4. So compare these parameters, who will become RP? Because the BPDO received from gigabit 00 and gigabit 01 directly from the root bridge. So the cost value will be smaller than the other two interfaces. So these two interfaces will be better. So then you have to compare some other parameter. We call it port priority because the cost value of interface are same. So you can compare the port priority. And the default value of the priority is 128. Okay, so later we will compare the port ID, the interface ID. Smaller will be better. And the gigabit 00 has smaller ID than the gigabit 01. So finally, about the switch 2, if you don't change any parameters, switch 2 will receive the interface gigabit 00 to become RP, right? You should change the priority on switch 1, sorry, not on switch 2. Enter gigabit 01. Spanner tree, the port priority 112. Okay, so you will change the priority. Then the switch 2 will choose a better BPDO received from switch 1. Show spanner tree summary. You will find now the gigabit 01 will become RP, right? Because I receive the BPDO is better than the BPDO I receive from gigabit 00, right? So this is the influence. The rest verification we already know you can check 4 requirements. Switch 1 should be the spanning tree, right? Should be the root bridge. We already meet the requirement. And about the switch 2, we hope the interface of gigabit 01 to become 01 to become our RP, right? And another one for the switch 4, we hope that the gigabit 001 can be our RP. So spanning tree summary. You will find our RP here. So we already meet our requirement. So in this configuration, you have to know what's the function of the bridge priority and what's the function of port priority. In the bridge priority, you must be an integer multiple of 4096. And about the port priority, we have some limitation of the 16. And some STP related, RSTP is derived based of STP. So the rule is very similar like the STP. But the principle of root bridge, RP, DP, and AP, and also backup, how to select it, it is same with STP. So this is the relationship with STP and RSTP. And about RSTP, we have some special scenario can provide faster convergence. So that's all about this lab. Thank you.